What if I told you that right now there are real images, crystal clear, ultra-detailed photographs taken from the surface of an alien world? Not CGI, not simulation. This is Mars in 4K. And what you're about to see will change forever the way you imagine the Red Planet. Because the Mars you know is nothing like the Mars you're about to discover. Every image in this video was captured by actual NASA rovers rolling across the Martian surface, alone, determined, unstoppable. Spirit, Opportunity, and Curiosity, 3 robotic pioneers that have gone farther than any machine before them. Their cameras, once cutting edge, now reveal something extraordinary. A Mars that looks real, textured, vast, barren, beautiful. For the first time, these images have been carefully restored and rendered in ultra-high-definition 4K, letting us see the surface of Mars as if we were standing there ourselves. The place names you'll see, like Glen Torridon, Namib Dune, and Vera Rubin Ridge, aren't science fiction. They're real, informal designations given by NASA's mission teams to map out this alien terrain. This isn't just a video, it's a window, and it opens onto a world few have truly seen. Let's get one thing out of the way. The reason we don't have high-definition video from Mars isn't because NASA doesn't want to show us. It's because they can't, at least not yet. You see, while the cameras on Mars rovers like Spirit, Opportunity, and Curiosity are incredibly sophisticated, designed to survive harsh radiation, dust, and extreme cold, they're limited by one simple truth. Mars is far, really far. Depending on the orbit, the Red Planet is between 54 million and 400 million kilometers away from Earth. That's like trying to send a message across the solar system using a walkie-talkie in a thunderstorm. And it's not just about the signal getting there. It's about how fast it can get back. The Curiosity rover, for instance, transmits data back to Earth at just 32 kilobits per second when communicating directly. That's slower than the internet your parents used to complain about. Now, you might be thinking, why not just upgrade the Wi-Fi? Well, there is a workaround. Orbiters like the Mars Reconnaissance Orbiter act like a kind of space-based relay tower, catching the data from Curiosity and forwarding it to Earth at up to 2 megabits per second. Much faster, yes, but there's a problem. This connection is only available for around 8 minutes per Martian day, which is called a sol. Imagine trying to upload hours of HD video with only 8 minutes of Wi-Fi per day. Instead of video, NASA prioritizes images, still high-resolution photos, often dozens per hour. Because Mars doesn't move much. No flocks of birds, no wind-swept trees, no bustling cities. So why burn precious bandwidth sending 30 frames per second when one perfect image tells the story? Each image that comes back is a piece of the puzzle. An out-of-context, dusty snapshot of an alien landscape. But once they're all stitched together, that's when the magic begins. And what you're about to see was built from that magic. What you're watching isn't animation. It's not a simulation. It's real footage stitched together from thousands of individual photographs captured across 2 decades of Mars exploration. But how do you turn still images into a journey? It starts with mosaics. When a Mars rover captures its environment, it doesn't take a wide panoramic shot like a smartphone. Instead, it takes a series of overlapping, high-resolution images, tiles, one frame at a time, like a scanner sweeping back and forth across the surface. Each photo is carefully planned, each angle calibrated. It's not just point and shoot. It's engineering precision. But back on Earth, those raw frames arrive as scattered fragments. Some are overexposed, others shadowed. Some have missing pieces. Sometimes the lighting changed mid-session. Dust, blur, even lens reflections. To create a single usable scene, teams have to color correct, align, and stitch dozens, sometimes hundreds, of images into a single continuous panorama. That's why you may notice black gaps in some frames. Those are places where no image was captured, either due to limitations in the rover's position or to protect power. And once a full mosaic is created, the team adds motion. Not by animation, but by using slow, cinematic panning across the panorama at 60 frames per second, preserving the ultra-high definition detail. No zooming in, no digital stretching. What you're seeing is Mars, exactly as it was photographed. Only now, it moves. This technique gives us something we've never seen before, a first-person view of an alien world created without ever taking a single step. But some of these mosaics go even further, reaching pixel sizes so massive you can zoom in and still see perfect clarity, and one in particular stands above the rest. Of all the images ever taken on the surface of Mars, one stands out, not just for its size, but for what it tells us about the planet's ancient past. Captured between November 24th and December 1st of 2019, this is the largest mosaic ever assembled from the Martian surface. It consists of more than 1,000 individual images, carefully aligned and calibrated to create a seamless panorama. The final product? 1.8 billion pixels. Yes, billion with a B. To give you perspective, if you printed this image at full resolution, it would stretch more than a football field in width. Zoom in, and the details don't blur. Rocks, soil grains, wheel tracks, it's all there, unfiltered, untouched. But where exactly was this image taken? The location is a region known as Glen Torridon, nestled at the base of Mount Sharp, inside Gale Crater, where the Curiosity rover has been slowly climbing for years. Glen Torridon wasn't chosen at random. This area was theorized to contain clay-rich deposits, a geological signature that could only have formed in the presence of water. And on Mars, clay is gold, because clay means one thing: ancient water. Stable, persistent, not just a flood, but a potential habitat. Scientists believe that billions of years ago, this area may have been a lake bed, fed by flowing rivers, shielded from radiation, and possibly even habitable for microbial life. As the rover panned its cameras across Glen Torridon, it wasn't just capturing pretty scenery. It was documenting layer upon layer of Martian history. Sediments shaped by time, by erosion, by the quiet presence of water that vanished long ago. You can see the texture of the land, the tiny ridges where wind has swept through, the cracks in the clay that hint at drying and shrinking, the subtle shifts in tone that suggest the presence of different minerals. This isn't just a picture. It's a geological map, a time capsule, and a work of art all at once. And even though the image is silent, the story it tells is deafening. We are looking at proof, not theory, but evidence, that Mars once had water, possibly in lakes or shallow seas. It changes how we see this planet. It reframes the question from, was there ever water on Mars? To, what else was there, and could something have lived there? What's even more fascinating? This isn't the only surprise that these images reveal. Because the next chapter doesn't just change how we see the land, it changes the sky above it. You've seen the Martian surface. Now, look up. Sometimes the sky above Mars is a faint, dusty red, like a planet trapped in permanent sunset. Other times, it looks strangely familiar, a bright blue sky, almost Earth-like. So, what's real? Here's the truth. Both are, in a way. Mars has a thin atmosphere made up mostly of carbon dioxide and filled with ultrafine dust particles. These particles scatter sunlight in a different way than Earth's atmosphere does. On Earth, tiny nitrogen and oxygen molecules scatter shorter blue wavelengths, giving us that iconic blue sky. But on Mars, the fine dust is so pervasive that it scatters longer red wavelengths, especially during the day. That's why, if you stood on the surface, the sky would usually appear pale orange or pinkish beige. Not red like blood, but not quite golden either. But wait, if that's true, why do so many photos from Mars show a bright blue sky? Because NASA sometimes uses a technique called white balancing. It's like adjusting the lighting in a photograph to make the colors of rocks and soil appear as they would under Earth-like conditions. Geologists on the mission teams use this to better understand mineral compositions, contrast, and surface textures. So when you see a vivid blue Martian sky in some images, it's not fake. It's processed to bring out details in the landscape that would otherwise be hidden in red haze. Think of it like this. One version shows you how Mars really looks. The other shows you how Mars would look if it stood under Earth's sunlight. Both are valuable, both are real. They're just different perspectives. But this also reveals something else. Mars isn't just one fixed shade. Its sky can shift, depending on the time of day, the season, and even the amount of dust in the air. During dust storms, the light dims to a deep sepia. At sunrise or sunset, the sky glows blue near the sun, the opposite of what we see on Earth. And all of this has been captured by the silent, unblinking eyes of rovers standing still on a planet that's constantly in motion. But the most emotional part of this story isn't just what the rovers saw, it's what they became, and how two of them made their mark on Mars before fading into its dust. Every great story has its pioneers, and on Mars, they were called Spirit and Opportunity. They weren't the first machines to land on the red planet, but they were the first to truly explore it. Launched by NASA in the summer of 2003, these twin robotic geologists were part of a daring plan to land on opposite sides of an alien world and search for evidence of ancient water. Each was built for one mission: to survive 90 Martian days, called sols, and travel no more than a kilometer. But what happened next defied expectations and captured imaginations. Let's begin with Spirit. She landed in Gusev Crater, a place scientists believed might have once held a lake. At first, the terrain looked bleak: fields of basalt, wind-blown dust, and scattered rock. But Spirit pushed forward, eventually climbing the Columbia Hills, revealing clues of hydrothermal activity, mineral veins, and the signature of once liquid water. Spirit wasn't fast, she wasn't flashy, but she was determined. She battled extreme temperatures, dust storms, and mechanical failures. She lost the use of one wheel, and still kept going by driving in reverse. And then, in 2009, after nearly 6 Earth years, she became trapped. Her wheels sunk deep into soft Martian soil. Attempts to free her failed. NASA turned her into a stationary science platform. She kept working until her final signal faded into silence. Her last words were data. Her final act, science. And now, Opportunity. She landed on the other side of Mars in Meridiani Planum, a vast flat plain filled with hematite blueberries, tiny mineral spheres that form in the presence of water. Within weeks, she found what she was sent to discover: definitive evidence that water once existed on Mars. But she didn't stop there. Opportunity kept moving. She crossed craters the size of stadiums. She survived multiple Martian winters. she climbed the rim of Endeavour Crater and explored its ancient rocks. Her journey covered more than 45 kilometers, a world record for off-Earth driving. But it wasn't just the science. People around the world began to feel something strange, an emotional connection to a robot millions of miles away. Maybe it was her resilience. Maybe it was how she kept going long after her mission ended. Maybe it was because she represented us, our curiosity, our stubbornness, our hope. And then, in June 2018, everything changed. A planet-wide dust storm, the worst in decades, wrapped Mars in a choking, sunless shroud. Opportunity's solar panels went dark, her batteries drained, and for months, she slept. NASA called, again and again. Over 1,000 commands were sent, but the silence was permanent. Finally, on February 13, 2019, NASA said goodbye. Her final transmission wasn't poetic, it was telemetry, but the team interpreted it in human terms. My battery is low, and it's getting dark. And just like that, one of the greatest explorers in history was gone. No fanfare, no funeral, just Martian wind and the whisper of dust over tire tracks. But her legacy? In every rover that came after, Curiosity, Perseverance, Ingenuity, there's a spark of spirit, a glimmer of opportunity. They taught us that even on a lifeless world, a machine could inspire emotion, loyalty, even grief. They weren't just tools, they were storytellers, and the stories they started are still being written. Just when it seemed like Mars had told us all it could from the ground, a new kind of explorer arrived. Small, experimental, and with wings. Her name was Ingenuity. Part of NASA's Perseverance mission, launched in July and landed on February 18, 2021, this tiny helicopter, no bigger than a backpack, carried a bold idea. Could we fly on another planet? Think about that. Mars has only 1% the atmospheric pressure of Earth. That's like flying a drone at an altitude of 30,000 meters. No bird flies that high. No helicopter has ever done it. But Ingenuity did. Her blades spin at 2,400 revolutions per minute, about 5 times faster than most Earth-based helicopters, just to generate enough lift in the thin Martian air. She weighs just 1.8 kilograms, yet her flight represents one of the biggest leaps in space exploration since the moon landing. Originally designed for 5 short flights, Ingenuity exceeded every expectation. She soared over alien dunes, scouted for danger, mapped paths ahead for Perseverance, and made history. She became the first human-made aircraft to fly on another world. But Ingenuity wasn't just a technical demonstration, she was a pathfinder. Her success proved something critical. Future Mars missions could include aerial scouts, capable of accessing areas that rovers never could. Steep cliffs, deep craters, collapsed lava tubes, even potential habitats. And while Perseverance continues her mission, searching for signs of ancient microbial life, collecting core samples, and preparing them for a future return to Earth, Ingenuity flies beside her like a companion, like a pioneer. Their mission is no longer just about Mars' past. It's about the future we might have there. But let's not forget, this leap into the sky was made possible by everything that came before, by Opportunity's wheels, by Curiosity's drills, by Spirit's quiet strength. Each rover built a piece of the path, until finally, someone dared to lift off from the Martian ground and enter its skies. And now we ask, if we can fly on Mars, what else is possible? Aerial networks across planets? Swarm drones to explore Venus? Hovering robots on Titan? The future of space exploration might not just be on foot. or wheel. It could be airborne. And it all started with a tiny helicopter that had no business succeeding, but it did. As you sit here on Earth, watching these ultra-high resolution images scroll across your screen, ask yourself one simple question. Did you ever imagine Mars could look like this? Not a blurry red dot in a telescope, not like a CGI rendering, but like a real place, dusty, distant, and alive with detail. These are not animations. These are real images, captured by machines we built, machines we launched across millions of kilometers, machines that landed and lived on another planet. You're not just watching a video, you're witnessing the surface of Mars through the eyes of explorers that never came home. And the truth is, we've only scratched the surface. Mars still holds its secrets, buried beneath dust, locked in rock, whispered in the winds that howl through empty canyons. Somewhere out there, the story of ancient water is still being written. Somewhere, the clue to life's beginnings may be waiting. And every image we bring back is another step toward answering a question older than civilization. Are we alone? Or are we just early? The beauty of Mars is not just in its red deserts or towering cliffs. It's in the fact that we're finally beginning to understand them. And if this blew your mind, wait until you see what's next. There's another journey waiting for you right now that will take your curiosity even further. One that might just change how you see the universe and your place in it. Tap into the unknown. Click into wonder. I'll see you in the next one.